Final part of this presentation is to take a look at several what-if scenarios using this Excel spreadsheet. See the table on the top has got some numbers plotted out based on the results of what we saw in our original scenario. And down below we see a graph. This graph is called a stacked area chart. And it gives us a visual representation of what was happening with our work completed, and it also gives us a representation of what our queues look like. So just to recap, recall that we played 11 story cards per iteration. The capacity for the BAs was 13, but because we only released 11 story cards into the system, the BAs only completed 11 story cards. Those 11 story cards were then passed over to the developers, and again, even though the developers had a capacity for doing 12, they were only able to complete 11 because that's what was passed through to them. You see here how the work in our web dev queue increased through several iterations because their capacity was reduced. And you see here also how the amount of work in the QA queue was increasing later in the sprint as their queue was building up. And here you see the actual numbers of what was completed per iteration. And so what we're going to do is we're going to plot those out on the stacked area chart. So the yellow area here is what represents the total number of story cards that were completed through the 10 iterations. Also notice the slope of the line is going to represent what our velocity was. So our velocity in the first iteration was 10, so the slope was 10. See how the slope kind of flattens out as it decreases from 7 to 6, and it increases back up to 10 again, and then reduces itself down to 8. So this is the amount of story cards that were completed. The top line here is reflective of the total number of stories that were put into play. And the difference between the top line and the yellow line here, the completed area, is the amount of work that is currently in progress. So seeing how we want to keep an eye on work in progress, we want to keep the distance between the top line and the line above the completed area down as small as possible. And the different colors here will represent where story cards are building up inside of queues. So the light blue area here is the total number of story cards that are building up in the web development queue. So you see that it reached a peak here of about 15. And then they started working their way through the queue. But really all they were doing is they were passing that queue over to the QA area, and you can see that the QA was never really able to make any progress on getting through that backlog. And you'll see that it took more than 10 iterations in order for them to complete out what this looked like. This kind of a chart is also referred to as a finger chart. It's a very powerful project management tool. But it's not something that you necessarily need because the information that we're seeing here is what you should be seeing on a daily basis on your Agile Story Card Wall, and you're going to want to make adjustments real time rather than taking a look at historical data. The historical data could be of interest, but it's not the primary thing that we want to learn through this presentation. What we're going to do is we're going to make some modifications to some of the numbers that we have up here in our table based on the application of some things like the principles of lean or theory of constraints. And the first thing that we want to do is we want to show you what happens if we localize the business analysts. In other words, if the business analysts have the capacity for dealing with 13 story cards, why don't we go ahead and release 13 story cards? Well, one of the things about theory of constraints is that you want to subordinate everything else to the constraint. Our constraint at the beginning was QA, so we want to subordinate the amount of work that is going to be done by the BAs, the devs, and the web devs to what QA's constraint is. So increasing the amount of story cards released into the system sounds like it might be a good thing because it'll keep these people 100% utilized, but look what ends up happening to the amount of work that goes into QA. We actually end up with more and more work backlogging up into QA. We don't accelerate the development process. It still takes over 10 iterations for us to complete this out. And we have an even worse situation than we had before with more stuff backlogging up into QA, and we know what the detrimental effect is there. So this is a very good visualization of what it looks like when you don't subordinate everything else to your constraint, but you just try to force as much work in progress into the system based on what your initial capacity would be on your first step of your workflow. So what we're going to do is, in the scenario, we want to actually see what the chart looks like if we apply the rope, the drum, buffer, and rope of theory of constraints to this. And by doing that, we're saying that we're going to reduce the amount of work in play to 7 story cards because we have tied the rope of our constraint, our drum of 6 story cards for web dev, which then causes us to only release 7 story cards into the system. And you'll see that we're way underutilized here in terms of BAs and devs. Look at the total amount of work that's taking place here. We actually get it done with inside of 10 iterations, so we're actually working faster. And we have less work building up inside of QA, so we know that we're going to be working much more effectively with developers and web developers, finishing story cards immediately and not letting them backlog themselves up. So again, subordinating to your constraint actually makes the system more effective. The last of the what-if scenarios that we're going to take a look at is elevating the constraint. So we know what our constraint is. Let's identify the constraint. Let's elevate our constraint, and our constraint is going to be QA. So what will the system look like when we elevate the constraint? Now, we're not playing the scenario of the web developer leaving the project. We just want to see what the project looks like if we put one more QA person strategically on the project. So recall that as we talked about our hopes for being able to get this project done with inside of 9 iterations, if our capacity on QA was just 10 story cards and we had 88 story cards to finish, we kind of had our eyes set on finishing this thing done in 9 iterations. But by strategically placing additional resources on our constraint, we're able to put more story cards in play because our constraint is now dev and web dev. We want to make sure we've got a bit of a buffer. So we've increased the number of story cards that we're putting into the system to 13. And you see what ends up happening. We get a bit of a backlog here with the web developers, but we get this project done in less than 8 iterations. This actually took 7.5 iterations to get done. So by strategically placing one extra resource on the project at the constraint, you can actually pull the date in and move this project in by an iteration and a half. So if you're thinking you don't have the finances in order to be able to strategically put another person on the project on the constraint, think of what you're able to do by getting your project done sooner, getting your software put into production sooner, and getting it to start generating value for the organization an iteration and a half sooner by putting one person strategically located on the project at the right place.